All right, good morning. Happy Wednesday. I know if you feel like me on Wednesdays, going through the whole schedule is draining, it's tiring, so I'm with you. I know it seems like a long day, so thanks for being here. All right, so the review for lesson 5.2 is due tonight, and we are going to have an exam on Friday morning on exam 5.2. Now, I'm going to do something special on Thursday. I'm going to hold a workshop, which I normally hold at school, but I'm going to hold a workshop at 2:30 for any questions on lesson 5.2. Now, you can come and go as you please, stay the whole time, but I do ask that you're there promptly at 2:30 because I'm also going to have a workshop for the pre-calculus class at 3:30. So workshop at 2:30. Just send me a message, send me a reminder saying that you would like an invitation, and I will send an invitation to your email. Okay, that's for the workshop on Thursday at 2:30. All right, we're starting a new lesson today, and you guys are going to be pleasantly surprised because it's not as hard as some of the lessons we've had recently. And so we're going to take a look at lesson 6.1. And lesson 6.1, we're going to add and subtract polynomials. So it's going to seem like we've done this before, but we haven't. So lesson 6.1. Okay, this is California Common Core Standard A-APR.1. It's also includes another standard F-BF.1b. And it also has some mathematical practice standards, MP1, MP2, and MP4. All right, so the first thing I want to do is I want to just recall some things from the past. And if you remember when I showed you an umbrella of polynomials, and under that umbrella, we had what? What was under that umbrella? We had linear functions. What else did we have?
We had linear, quadratic, cubic, quartic, quintic, 6th degree, and 7th degree.
Thank you. Who is that? April, thank you. That's right. So I'm going to show you this another way. So this is another representation of what I showed you. The name is a constant. The degree is 0. And an example would be negative 9x to the 0. Because what's x to the 0? Do you recall? What is x to the 0?
Isn't it 1? 1?
Yes. Yes. So that doesn't this mean negative 9 times 1, which is negative 9?
Yes.
Yeah, and you're super familiar with linear. The degree is 1. And what would be an example of a linear expression? What would be an example of a line? X minus 4? You guys are going to do the next one. I'm not going to do the next one for you. Looking for my rag, it's in my hand. Quadratic, the degree is 2. So give me an example of a quadratic. Go ahead, I'm listening. An example of a quadratic. Hello? Hello, nobody's talking to me today?
Can it be x squared plus 4?
Sure. Is that a quadratic? Is that an example of a quadratic?
Yes.
Sure, that's perfect. And if we felt like saying x squared plus 4x minus 1, that's also an example. So there's an infinite number of examples, right? All right, so what about a cubic? What's the degree?
3.
Okay, give me an example of a cubic.
Would it be x to the power 3 or cubed? And then plus, we can do any number, right?
Sure can.
5.
Okay, perfect. Okay, the next one would be a quartic, right? And it keeps going on in this fashion. What would be the degree of a quartic?
4.
4.
What would be an example of a quartic?
X to the power of 4 minus 2.
Okay, perfect. And you can go on and on like this, right? Okay, so what I'd like to do right now, that was a little bit of just a warm up. What I'd like to do is I'm going to share my screen. And this is always in the way. All right, now I started this. I wanted you guys to see, you're going to go to your interactive textbook, which you're very familiar with doing. And go to Unit 3. And we're going to pick polynomials. And we're going to pick adding and subtracting. Now, some of this you know, so it's being scaffolded in to some new concepts. And I'm going into the Explore here. All see my screen?
Yeah.
Yes, we can.
Okay, so you're familiar with it. Polynomial, poly means many, nomial means terms. Function means what? Function? What does function mean? What does a function tell you about the graph? Hello? A function? Nobody can tell me anything about a function? Hello out there? Can you guys hear me?
The function is, oh yeah, I hear you now. The function is related to the set of inputs and outputs.
Okay, a function has a unique set of x's and it passes the vertical line test?
Yes.
Okay, so while we're here, let's just do this. What is this a sub n? Do you remember what that's called? Do you remember what the number in front of, well, let's start with n then. What's n? When this is in standard form, what's n?
The degree.
The degree. And what is a sub n? It's a number, right? And what is that called?
Wait, what did he ask again?
I want to know what a sub n is called.
The leading coefficient?
Thank you. That's right, the leading coefficient. And then what is this a sub 0? Do you remember what this is at the end? I know I haven't tested you on this form, so you guys are doing a good job.
The constant. The constant term?
Yeah. All right, so let's take a look at this. It's saying that this is a polynomial in standard form. That means in descending powers of x, has nothing to do with the coefficients. It's called a polynomial, and each term are called monomials. So last time we talked about each one of these being a term, and now we're calling these terms monomials. Mon means one. And I want you to notice that the monomials are separated by plus and minuses. Let's go to the next one. So, definition that I want you to write down. So the first thing I want you to write down is that a monomial is a term. I'll more explicitly in a minute. Right here, a monomial is actually a number or a variable or a product of numbers and variables. So once again, a monomial could be a number, it could be a variable, or it could be a product of numbers and variables with whole number exponents. And I want you to write this definition down. A polynomial is a single monomial or a sum of monomials. That's why the definition is many terms. It could be one term, or it could be a sum of terms. All right, does anybody need more time before I scroll down?
Yeah.
Okay. Now, when you're writing these definitions, you don't have to write word for word. You know, you want to write something that makes sense, obviously, but you're not copying the page. It's too much work. Can I go on?
Yeah.
Oh. Only one person saying go on?
Yeah.
Go on.
Oh, okay, thank you. Okay, so the degree of a monomial, so the degree of a term is the sum of the exponents of the variables. So they're looking, see, we've looked at the degree of a polynomial. We already know what that is. The degree of a polynomial is the degree of the term with the greatest degree. And now we're looking at the degree of a monomial. And what we have to do is we have to add up the powers of the exponents of the variables. And then finally, you know this already, the leading coefficient of the polynomial is the coefficient of the term with the greatest degree. Okay, so we're going to do some exercises here. I thought this would be interesting and quick. So let's take a look at this. It says identify. So you see this 2y to the fourth down here? Do you think that that's a monomial or not a monomial? So what I'm asking you is it a number or a variable or a product of numbers and variables?
Yes.
Monomial? What about 25?
Can it be a product of?
Well, we said the definition of a monomial was a number or a variable or a product. So is this a monomial or not?
Yes, it is.
Yeah.
Well, we're going to check in a minute. All right, what do you guys think about this long thing? This is a sum. Do you think it's a monomial or not?
No, that's a polynomial.
Okay, I think you're right, but we'll check in a minute. Okay, what do you think about this guy? A cubed times b to the 12 times c. Do you think that's a monomial or not? Is that a product of numbers and or variables?
Yes.
Yeah. Yeah.
All right, we're going to check and see if we got them right. And yes, we did. Are you all able to see this okay?
Yeah.
Yeah, we
All
could
right.
see.
So now they're of each monomial. Now, remember the definition said when you're finding the degree of a monomial, you add up the powers of the variable. So what do you think this degree is of this monomial?
4.
4.
Okay. What do you guys think?
0.
Yes. Okay. What do you guys think this degree is?
Would it be 16?
I don't know. Let's see.
Yeah, I think it'll be 16.
Okay, everybody unmute yourself and tell me, do you think this is correct?
Yes.
Yeah.
Anybody else? Anybody else want to chime in?
Yeah, I think it's correct.
Okay, well, let's see. Yay, give yourself a hand. I can't hear you. Give yourself a hand. Good job. All right, now, identify the terms of the polynomial. So you have to drag up. What would be the terms of this polynomial? Go ahead, I'm listening. Is 15 one? Term of the polynomial? Can you guys hear me?
Yes.
Okay. Is negative cubed a term of the polynomial?
Yeah.
I don't know. Let's see. Is 7x squared a term of the polynomial?
Negative 10, 5.
Yeah.
Yeah. Okay. What about negative x cubed?
No.
No.
What about positive 4x cubed?
No.
What about x?
Yes.
Yeah.
Okay. So let's check ourselves. Correct. Give yourself a hand. All right. Identify the coefficient. Now remember, the coefficient is the number being multiplied to the variable. So what is the coefficient of x?
Ms. Birch, I had a question about the when we identified the terms.
Okay.
Why aren't negative x squared cubed and 4x cubed terms?
Okay. Do you see a negative x cubed up here?
Oh,
Or
okay.
do you see a negative 4x cubed?
No. Okay. Thank you.
You okay? Okay,
Yeah.
no problem. Yeah, no problem. Okay, what's the coefficient of x?
Would it be 1?
I don't know. Looks like it maybe. What's the coefficient?
7.
Take that. What's the coefficient of this guy? Somebody different.
4x minus 10.
Negative.
Negative. Is that what you said? Yes, no?
Yeah, negative 4.
Negative 4.
Okay. You're correct. Good job. So now we're identifying the degree of this term. So what's the degree of this term?
0.
Okay, isn't x to the 0 1?
It's 1.
Oh.
You want to change your mind?
Yes.
What's the degree of this guy?
2.
The degree of this guy?
3.
3.
What's the degree of this guy?
Would it be
0.
0.
0.
X to the 0, right? Good job. All right. So if we want to write this polynomial in standard form, what would we write? We have to select an answer. Do you think it's A, B, C, or D?
C.
C. C.
C.
All right, let's check it out. You're right. And finally, what is the leading coefficient?
Would it be -4?
-4x cubed.
Hold on, the leading coefficient.
Yeah.
We don't want the term, we want the leading coefficient.
Would it be 7x squared?
The leading coefficient, if the degree is 3, the leading coefficient is what?
-4.
-4.
Okay. All right, good job, guys. Give yourself a hand. All right. So let me stop sharing my screen. Hey, can you see me?
Yeah, we can
Yes.
see you.
Yeah.
All right, good job on that. That was a good review of the vocabulary because now it's not going to seem like I'm speaking a foreign language. All right, so let's look at adding and subtracting. You're going to love this. We are also going to look at some modeling. I don't know if we'll get to it today, but we just got through modeling with the cubic polynomial, looking at the maximum volume of a box with a side flap of X. Remember that? You guys did a good job with that. Okay, check this out. Can you see my screen?
Yeah, we can see the board.
Okay. So there you go. So what do you, before I even teach this, what do you guys think you're going to do?
Combine like terms.
Yes, you're going to combine like terms. And what makes like terms like terms?
They have the same variable.
Raised to the same
Power.
Power.
power. Okay, so we could put these in standard form and then add if we wanted to. So let's just do that. Let's put these in standard form. So this would be 5x to the 4th minus x cubed plus 4x squared plus 2 plus, and I don't think we need these parentheses anymore, 3x to the 4th plus 6x squared minus x. And we're just going to put the like terms together. Now, the reason why I did this is so you could see the terms more clearly, because it is a little confusing with them all. So what's 5 plus 3?
8x cubed.
8x to the 4th?
4th power, sorry.
Okay. And then he goes with nobody, so that would be minus x cubed. And this guy goes with this guy, so that would be what?
Plus 10x squared.
10x squared. What is it? Minus x plus 2? Can you guys unmute yourself and tell me, does this look correct to you, or did I make a mistake?
It's correct.
It looks good.
Okay, cool. All right. So that was addition. I'm not even going to do another problem. This is 12x cubed plus 5x minus 8x squared plus 19 minus 6x squared minus 9x plus 3 minus 18x cubed. Wow, it's long. So you tell me, what do you think is going to be a common mistake?
Maybe they don't multiply the
They don't
negative.
distribute the negative.
Okay, but you're not going to be one of those people, right? You're going to distribute the negative, right?
Yes.
All right. Okay, so let's put this in standard form. So the highest degree would be 12x cubed. What's next?
8x squared.
Plus 5x plus 19. And we're going to distribute the negative and write it in standard form at the same time, unless we get confused, then I won't do that. But wouldn't this be positive 18x cubed?
Yes.
Plus, okay, then this would be minus 6x squared plus 9x minus 3. Now, if anyone is confused about that, I'm going to redo it. So please unmute yourself and tell me, are you okay or not?
Okay.
Anybody else okay?
I'm okay.
Yeah, I'm still writing.
Okay. Okay, so here we go. What's 12x cubed and 18x cubed?
20x cubed.
20
Oh,
or 30?
30. Sorry, I thought you said 2x.
No, that's okay. You're good. You're good. What's a negative and a negative?
Negative.
A positive.
And you, a positive?
had-
Did I hear that?
Sorry, I got confused.
No, you're okay. We're okay. A negative and negative is a negative when we add. So what's 8 and 6?
14.
Okay, moving right along. What's 5 and 9? 14x? Yes, no. And what's 19 minus 3?
16.
Okay, unmute yourself if you think this is right.
Looks good to me.
Yeah, it's right.
Yeah, okay. All right. Okay, I think what we're going to do is I'm just going to give you a couple problems and you're going to go into your teams just for me to assess that you know what you're doing. And we might have to do these applications, these modeling problems with geometry and the Census Bureau problem. We might have to do that some other time. All right, so here's what I want you to do. You are going to work these two problems, and here they are. The first one is 10x minus 18x cubed plus 6x to the fourth minus 2 plus negative 7x to the fourth plus 2x cubed plus x plus 5 You guys see that?
Yeah, we can see that.
Now, do you think that's an addition problem or subtraction?
That one's an addition problem on the top.
You're right. Okay, do you guys have this written down?
No.
Is this an addition problem or subtraction, the second one?
A subtraction problem.
Okay. So guess what? I'm going to give you about 5 minutes to do this in your groups. And then you're going to report back. So let's say this. It's 11:39. Yeah, let's do that. You're going to report back at 11:45. So let's see how you do. All right, so I'll see you back here in WebEx at 11:45, and I'll see you in your Math Wizard teams.
Ms. Birch,
Yeah.
a quick question. For the first problem, it's -7 plus 2x?
It's negative 7x to the fourth plus 2x cubed.
Okay, thank you.
Can you see that?
Yeah, I can see it now.
Yeah, my
And it's
pin's
plus 5, right?
Yeah, plus 5.
Yeah, it's just
And now
right
go
side
ahead.
is blurry.
I know, my pen is going in and out. So can you see it now?
Yes.
Okay, I'm going to change the time now. So you're going to leave and you're going to be back at 11:50. All right? 11:50. I'll see you in the Teams. Hi, everybody. Did you make it back?
Yep.
Hello, is everybody back?
Yep.
Yes.
Yeah, we're here.
So how did it go? Did you guys agree with your answers?
Yeah, we did it pretty quickly.
All right, good job. I'm just going to read out the answers real quick. So this first one, did you get in standard form, did you get negative x to the fourth minus 16x cubed plus 11x plus 3?
Yes.
Yes.
Yeah.
Okay. And for the subtraction problem, did you get negative 15x to the fifth plus 8x cubed minus 6x squared plus 10?
Yes.
And you want to make sure when you're in those Math Wizard teams, you want to make sure that everyone is included in the group. You want to make sure that everyone was able to contribute and come up with the same answer. You want to make sure everybody gets an A on the exam, right?
Yes.
All right, give yourself a hand. All right. Look in your books, please, on page 274. We're not going to be able to do this today, but for those of you who like to venture forward, you can. I'm reading at the top of the page and we're looking at modeling. So many real world situations in fields ranging from education and business to engineering and physics can be modeled by polynomial functions over a restricted domain. And we saw that with the box problem in the last lesson. So polynomial functions at the top on page 274 can be used to model real world quantities. And so if two polynomial functions model equations that are two parts of a whole, couldn't you have a total in terms of x equal to part 1 of x? Which is an addition problem. And I could write my own equations from this if I felt like it. Like if I subtracted part 2 from x, wouldn't I have part 1 of x is equal to the total in terms of x minus part 2? And in the same way, I can solve for part 2 of x. And if I subtract part 2, I would have the total in terms of x minus part 1. So there's 3 different equations that we can use depending on the problem. So the first one is a sum. The second 2 are differences. So I think you're going to be able to read these modeling problems and you're probably going to be able to do them on your own without me even teaching it. But the next time we get together, we're going to do some modeling. We're not only going to look at the problems on page 274, but we're going to look at some geometry problems. And I think from what we've done previously, you're going to find them to be pretty easy. So anyhow, this was most of adding and subtracting polynomials. and you guys did a really great job. I have posted the assignment in Google Classroom, and I will continue with this in the near future, like tomorrow. All right, anybody want to ask me about anything? Kind of running late today, so I apologize. All right, great job today, you guys. Have a great day. All right, I will see you tomorrow. Have a good day.
Bye, Miss Bird.
Bye, babe. Have a good day. Bye, guys. Have a good day. Have a good day.